Hello and welcome to the second part of section 7.2, using x and y intercepts to graph. Now yesterday we took a look at plotting points in order to graph a particular line. So today we're going to actually take a look at using some very specific points. Instead of just selecting random points, we're going to find x and y intercepts, which are two very specific and often important points that we will want to know on any graph. So let's start by defining what is an x-intercept. Well, an x-intercept is the point where the graph crosses the x-axis. So when we're looking at these points, you will find that all of them will be on the x-axis. So with that definition, I bet you can probably figure out what the y-intercept definition would be. Well, if you haven't guessed it, it's very similar to the x-intercept. It's the point where the graph crosses the y-axis. So you could almost rewrite exactly what we have for the x-intercept, but it's where it crosses the y-axis. So one very important point to note here is that when we're talking about the x-intercept, notice that it is where it crosses the x-axis. When we're talking about the y-intercept, it's where it's crossing the y-axis. So there is a definite connection there. So let's take a look at a couple of points and see where they actually end up falling. So I'm going to pull up a little grid here and see if we can take a look at what happens with some points. So recall that our definition for x-intercept is that it's a point where the graph crosses the x-axis. Well, remember this right here is your x-axis. So if I were to look at, for example, this point here, this point is on the x-axis. So think about the coordinates for that point. Well, if you're careful, you will come up with the point 3, 0. What if I had selected this point here? Well, that has coordinates 1, 0. How about over on the other side here? Well, that point is negative 2, 0. Now, do you see anything that all three of these points have in common? Well, you might notice that all three of them have a y-coordinate that is 0. It's 0 in all these situations. So now let's take a look at some other points. Suppose I were instead to look at this point right here. Now notice this point is now on the y-axis. And what are the coordinates of that point? Well, that point is going to be 0, negative 3. And if I look at this point here, I have the point 0, negative 1. If I look up here, I have the point 0, 2. And you'll see that there's a common relationship with the y-intercepts as well. Notice that the x-coordinates are all, in fact, 0 when you're looking at the y-intercepts. So this is a very important relationship. It's also sometimes a difficult one, especially if you have any dyslexic tendencies. So you want to be very careful with your x-intercepts and your y-intercepts to make sure that you are listing the coordinates in the correct order. So now let's go back to my previous page where I had those defined. And let's take a look at how we're going to use the x and y intercepts in order to sketch a graph. So as before, I'm going to take a look at some steps. I know for some of you that can be very helpful. So here are the steps that I will follow. First of all, I'm going to find the y-intercept by letting my x equal 0. Now remember, with all the points we just looked at, with the y-intercepts, it was 0 and a y value. So that's why I can let x equal 0. So I'm specifying a very specific x value. The second step is to find the x-intercept, but this time I'm going to let my y equal 0. So again, the x-intercepts all have an x value, and then the y-coordinate is always 0. So I've got two very specific points I'm going to find here. Now, because it's easy sometimes to mix these up, to make sure you have the correct graph, I like to put in step 3, which is to find one additional point. And you can do this exactly the same way as we did for point plotting. So any point you like, find one additional point. Then you're going to plot the 3 points to see if they are collinear. And hopefully they are. You've done everything correctly. And so then you will draw a line through the points and put arrowheads on either end. Now, we talked about this yesterday, but the reason we put the arrowheads on either end is again to indicate that the line does continue on beyond the graph that we're looking at. So let's go ahead and go through these steps with an actual example. So the example I'd like to look at is I'd like to graph 4y equals 8x plus 16. Now notice that this is not in the form that we were looking at yesterday. It's not in standard form, it's just kind of in a random form. And the nice thing with using x and y intercepts to graph is that we can use it, any equation in any form, to be able to sketch the graph. So I'm not going to change this one at all. I'm going to leave it just as it is. And I'm going to go through my my steps. Now the first step, remember, is to find the y-intercept by letting x equal 0. I really could do steps 1 and 2 in any order, but I'm a creature of habit, as I've often said, so I like to find the y-intercept first. So if I let x equal 0, this equation is going to become 4y is equal to 8 times 0 plus 16. And so solving, I simply get 4y equals 16. Divide both sides by 4, and my y value is 4. So the coordinates of that particular point are, again, I plugged in 0 for x, and my y value is 4. So there is one point that should be on the graph. Let's do the second step, which is to find the x-intercept by letting my y equal 0. So now I'd have 4 times 0 is equal to 8x plus 16. So 0 is equal to 8x plus 16. A little more solving to do here. So I'm going to go ahead and move my 16 over here. I'm going to be a little bit different. And I get negative 16 is equal to 8x. So divide both sides by 8. And x is equal to negative 2. So a second point that I have is the point negative 2, 0. Now again, it only takes 2 points to graph a line, but to ensure that I have the correct x and y intercepts here, I'm going to find one additional point as noted in step 3 here. So we can choose any value that we want here, and I'm going to choose a value of, say, x equals negative 1 and plug that in. So I'm going to look at 4y is equal to 8 times negative 1 plus 16. So 4y is equal to negative 8 plus 16. Well, that's going to give me 8. Divide both sides by 4, and y is equal to 2. So an additional point here is I plugged in negative 1 for x. I came out with a y value of 2. And so I now have 3 points that I believe are on the graph of this particular linear equation. So now let's go ahead and move to our graph and see if those are actually going to be collinear. So 0, 4, 1, 2, 3, 4 is going to be right here. Negative 2, 0 is going to be right here, and negative 1, 2 is right here. And look, they are collinear. They do line up. So therefore, I know I have the correct graph. I can sketch my line through those 3 points, put my arrowhead at either end, and I now have the correct graph for this particular equation. Okay, now there's a couple of things that we have to watch out for when graphing. We happen to have a couple of special lines that we need to pay attention to. So I want to talk a little bit about 2 special graphs that we might run into. And I bet you can guess what those graphs are. We talked about them when we talked about slope. They were 2 special graphs we looked at then. The first one I want to take a look at is the horizontal line. Now, a horizontal line is the graph of an equation in the form y equals b. Now notice this is a very simplified version of our linear equation, and we'll relate that in just a moment, where the y-intercept has the coordinates of 0b. So notice the tie-in between the b and the equation and the tie-in with the b and the y-intercept. So let's take a look at an example here. For example, if I am using this particular equation right here of y equals b, then I'm looking at something, for example, like y equals 3. Now, according to this, it is a horizontal line whose y-intercept is 0b. So that means it's 0, 1, 2, 3 is the y-intercept, and a horizontal line would go through that point in this direction. So there is the graph of that equation. So what exactly does that mean? Well, basically, if I look at any of the points on this line, for example, right here, that has coordinates 3, 3. This has coordinates 2, 3. This has a coordinate of 1, 3. Every single y coordinate is always going to be 3. So another way to think about it is we talked about the general form of an equation, and we always said that, well, we can write that in the form ax plus by is equal to c. Well, in this particular case, our a value is 0, so we have 0x, plus our b value is 1, so we have 1y, and our c value is 3. So if we simplify this, again, 0x is just 0, and so y is equal to 3. So it's a very special case of the linear equation that we looked at earlier. So that's a horizontal line. It will always have the equation y equals because the y value is what stays constant. All right, so our other special graph that we need to look at then, of course, is the vertical line. And a vertical line, very similar to the horizontal line in its definition, but it is the graph of an equation in the form, and here's where the difference comes in, that's x equals a, where the x-intercept is a comma 0. And so we're now looking at a different kind of line. So let's take a look at an example here. So the example I'd like to look at here is x equals 4. So if I'm looking at x equals 4, it has a x-intercept of 4 zeros. So 1, 2, 3, 4. There's my x-intercept. And it is a vertical line through that particular point. All right, so it's a vertical line here. It goes through an x-intercept. And again, similar to the horizontal lines we looked at, if I look at any point on here, notice that the x-coordinate is always 4. So this is 4, 1, 4, 2, 4, 3, 4, negative 2. The x-coordinate is what stays the same in every single point that we look at. And so if we again think of it in the terms ax plus by equals c, in this particular case, we actually have our b value that's 0. So our a is 1x, our b is 0y, and our c value is 4 this time. And notice that in this particular case, 0y drops out, and we end up with x is equal to 4. So it does fit, again, into the standard form of a linear equation. It's just that this time our b value ends up being 0. So these are two special cases that you will want to remember and know how to graph. And keep in mind that they do have different forms. The vertical line is always x equals something. The horizontal line is always y equals a value. So that finishes up section 7.2. I'll do another short video with another example of using the x and y intercepts to sketch the graph of a line. If you don't feel you need that, you can go ahead and check the website for the assignment.